today we're going to start talking about angles that are on the coordinate plane. And we do that by having the vertex of the angle at the origin. So we're going to start at the origin. There is some vocabulary that I'm going to try to say as often as possible so that, did you not get it? So that you start learning it. So I would encourage you to use this vocabulary also. Look at the picture. So what we have is we have an angle that has a vertex at the origin. The vertex is at 0, 0. And we have the first side of the vertex called the initial side. How can we remember that the initial side is the first side? It's initial mean, starting first. And then the other ray from the angle rotates around, and that side is called the terminal side. And what does terminal mean? Stop. Ends. Yeah, that's where it stops. The terminal side is where it ends. You will notice the direction that this angle is rotating. If we think with a clock, this direction is what? Counterclockwise. Anti-clockwise? Sorry, that word. So counterclockwise. Today is going to be a good day. You got to put fun in it if you want to get fun out. All right. So standard position starts on the. We're talking about the which axis, but which side of the x-axis? Right. But that's not going to be the right x-axis. It's going to be the positive. The positive. The positive x-axis. The initial side. The initial side always on the positive x-axis. The terminal side, the ray that rotates. I didn't say this yet, but oh yeah, we kind of said it, but positive angles rotate counterclockwise. And then negative angles, we can have negative angles now. Negative angles are just telling you the direction that they're rotating is not counterclockwise, but it would be clockwise.
Still positive value.
What do you mean?
Still a positive value for the actual angle.
Yeah, when you actually look at the angle would be measured in a positive value. The negative just tells us the direction it's rotating. That's the only thing that the negative tells us is the direction. So here's a picture where you can see the initial side, the terminal side, and then this one here would be counterclockwise, so it would be a positive angle. And this one over here would be clockwise, so it would be a negative angle. Okay? Example 1, we're going to do this together because I want you to kind of be detailed. You are now 10th, 11th graders. We can draw a detailed angle. 240 degrees. You're going to start with your coordinate plane, and we're going to label some angles. So I'm going to start at the initial side. That would be 0 degrees. The positive y-axis, what degrees is that one? No, it's 90 degrees. The negative x-axis would be 180, and then 270, and then 360, and then 450. Yeah, 450. I actually didn't know either. I was just saying 450. But it could go to 450. We could keep going around forever if you want. Keep going around because that's what circles do. We'll just label it. All right, and then we're going to draw our initial side. Where is the initial side going to go? On the positive x-axis. We're going to start with the vertex at 0, 0. Positive x-axis, there's our initial side. And then the terminal side, the ray is going to rotate 240 degrees. So we are going to draw this rotation. I'm going to start somewhere here, and I'm going to start rotating 90, 180. How much is left?
A lot, not all the way.
60 more to get to our terminal side at 240 degrees. So the red rotation, that theta, is the 240 degrees. But there is something that we are going to start looking at. It always has to do with the x-axis. What's the angle with the x-axis on the terminal side? Right here. What's that angle? That's 60 degrees. I kind of asked you that question. How much past the 180? So we're gonna kind of label that in there too. But the red spiral and the blue angle is really the answer for that. 60 is not the answer for that. It's the spiral. Okay, so let's do B. Question? So we're going to start and we're going to label our axes 0, 90, 180, and 270 degrees. Before we go any further, if you're not writing a degree symbol, it's a very bad habit to be in, because the degree symbol tells us that we are in degrees. Halfway through this lesson today, we're not going to be in degrees anymore. So I have to be able to tell between degrees and the other thing, which is called radians. I have to be able to tell between the two. You have to have the degree symbol if it's degree. Okay. So we're going to have our initial side. And then this one is 500 degrees. So we're going to start rotating around. I'm going to make one complete circle because that's 360 degrees. How much further do I need to go? 500 minus 360 is 140 degrees. So I'm going to go another 90 and then another, like, I think 50 more. Notice my red spiral has an arrow on it because it's showing the direction that we rotated.
When we do like our homework and our quizzes, do you want us to jump spiral too?
Yes, that is part of it. Because I need to know that it's 500 degrees and not, what angle does the blue angle look like if you didn't see the spiral? It looks like 140. So I need to know that it's 500. So that's why the spiral is there. And then what angle is left to get me to the x-axis? 40. So that's going to be important too. So we're just going over it now. It's not really part of this lesson, but we're just going over it now. You have more practice with it. All right. Next one, draw your 0 degrees, 90 degrees, 180 degrees. Oh, wait, no. Oh, what did I do wrong? It's going negative. So I'm going to write negative 90 degrees, negative 180 degrees, negative 270 degrees. What happens when I'm not thinking ahead, when I'm not looking ahead? Have to erase. Draw our initial side, and then we're going to go negative 50 degrees. So we're going to take this and we're going to go clockwise 50 degrees. And then according to the x-axis, what is that angle right there? Well, the angle itself is 50. The direction that we went is negative. But the angle itself is just 50 degrees. Okay, the negative, again, is only telling me the direction I'm rotating. All right? You try. You got 4 of them. You try. And pause the video. You help me remember to unpause it, okay? Sometimes I forget. Since we're talking about this angle anyway, we're going to learn about it in our next lesson, really. But this is called the reference. Reference. Is that right? Angle. called the reference angle, and it's going to be pretty important. That's what the vocabulary word is for that angle. It's called the reference angle. We're going to refer to it a lot. For negative 120 degrees, I'll just do the rest of these. Negative 120 degrees. I'm going to go negative 90 here. We're going to start at the initial side, and we're going to go 120 degrees in the negative direction in the clockwise. And then we look at our x-axis. And what is the reference angle to the x-axis? 60. And then the last one's negative 450. So I start spiraling, and I'm going to go all the way around. How much do I have left? 90 left. So I'm going to go to here. So that is a 90-degree angle. What angle is that 90 degrees the same as? Say again, you're right.
270 degrees positive.
Yeah, it is the same as positive 270 degrees. It's the exact same place if you just count it positive. So now what we're going to do are co-terminal angles. Co-terminal. Terminal means what? This ending side. To be co-terminal, co means in English. What?
With.
And with together. Co-terminal. What? I'm sorry.
End in the same place.
Yeah, they're going to have the exact same ending place. So where I had negative 90 degrees, and you guys told me, well, that's the same as 270 degrees, those angles are co-terminal. Because they're the exact same ending place. I could have, we'll say it one more time, I could have my angle being negative 90 degrees. It was negative 450, wasn't it?
Yeah.
Okay, so negative 450 degrees is the same as negative 90 degrees. It's coterminal. It is also the same as positive 270 degrees. Those are all coterminal angles. It says that their terminal sides coincide, and coincide means that they lie on top of each other. So when I'm talking coterminal angles, what can you tell me about the value from 270 to 90? Or the value, the difference from negative 90 to negative 450? What's the number, the difference between those? Again, from negative 90 to positive 270. What's the value? What degree? Huh? 360. If I start at negative 90 and I go all the way around to positive 270, that's an entire circle. And if I go around again, 360 degrees. And I go around again, 360 degrees. How many times can I have coterminal angles? How many? Just go as many times as you want. You can add 360 and then add another 360 and then add another 360 and then add another 360. And those are all going to be coterminal because it just makes a circle and it keeps landing in the same place. Can we subtract 360?
Yes.
You can go the other way. You can keep subtracting 360. So this sets find one positive and one negative angle that are coterminal with negative 45 degrees. So we're going to start with negative 45 degrees. You can either add 360 or you can subtract 360. You can add multiple 360s or subtract multiple 360s, just always 360. So when we do that, what happens if I add 360 on the negative 45?
It's 360 minus 45.
Plus 360 degrees. What do we get?
315.
315?
Yep.
Is that a positive or a negative coterminal angle?
Positive.
Positive. So we still need to find a negative coterminal angle. What should we do?
That one. Do nothing to it.
No, because then it would just be the angle. It wouldn't be coterminal with this angle. So we need two. We need two negatives. All right, so we're gonna do what?
Subtract 360.
Subtract 360. Negative 4 what?
05.
05. And that gives us a negative angle. Notice how I wrote degree symbols after every single one. Because if you don't write degrees, it means radians, and these are not radians. You haven't learned what radians are, maybe last year, but you haven't reviewed it this year. So question B is 395 degrees. We need to find a positive and a negative coterminal angle. What should we try? Nick? You can subtract 360 and get a positive. Yeah. What do we get?
35.
35 degrees. That is a positive. So does that mean I can add 360 to get a negative? No. What do we get?
Subtract 360 again from the 35.
Okay. So you could subtract 360 from the 35 and get a negative, or you could also think about it being like 395 minus 2 360s, which you don't have to do it that way. You can totally just subtract 35 minus 360. I'm just saying, like, what we're really doing is we're taking the original and subtracting 360 twice.
Negative.
What is it?
Negative 325.
All right, you've got 4. You try. Find one positive and one negative. Of course, if you have your calculator, you're going to fly through this. Hopefully. Or 90 radians? Is that what you meant? I mean, we haven't learned about radians. We're about to, but if you guys don't put the degree symbol, I'm assuming that you're writing it in radian form, and that would be way, way, way wrong. So you're doing all your constants first, or? Okay, just check. Alright, we'll write some answers out. There are infinitely many different answers. There are. So I'm going to put like the most obvious ones, the easiest ones, the ones you probably have in your paper, unless you're trying to be super creative. Very special. All right. Any questions so far? This is super easy so far. Hope so. This stuff will be on your quiz tomorrow. So you're not going to really have like a day of review. You just have to know it when you come in. You got to know your, what's the other stuff we did in here? SOHCAHTOA. Trigonometry. You have to memorize the chart by tomorrow. You do not have to memorize the chart by tomorrow. But what's the sine of 30?
1/2.
What's the sine of 45?
Negative or radical 2/2.
What is the sine of 60? Radical 3/2. So it's like 1/2, radical 2/2, radical 3/2. Those are the three signs.
Whoa.
So it's really radical 1/2, radical 2/2, and radical 3/2. What's the cosine of 60? Same as the sine of 30.
Oh.
What's the tangent of 30? Radical 3/3. The tangent of 30 is the one that has all the 3's in it. Tangent of 30 is radical 3/3. Okay, good review. All right, this is not on your notes. We're just going to discuss this, and if you want to jot any of it down, you can. But what we're doing next, radians, they come from knowing the circumference. What is the circumference like at all? Like what is the length around the circle? Right, the length around the circle. So how do we find a circumference? What's that formula? So what's pi r squared? Because this is not pi r squared. Yeah, that's the area. Yesterday, that's what everybody was telling me. You could do pi times diameter, but we will not really be doing diameters for this chapter. We're more going to have radii. So we're going to think radius. So for this particular circle, what's the circumference? What's the radius? Right. How are you getting that?
Origin to one of the points.
You see there's an ordered pair sitting there? That picture is in your notes somewhere. I think it's on the front page, but you see there's an ordered pair sitting there?
Whoa.
That tells us that the length from 0, 0 to that point is 1 log. So this is called a unit circle. This is called a unit circle because the radius is 1 unit. So the circumference of this circle is 2 pi times 1. 2 pi. Okay? So now using that, we come up with some measurement for circle, or not circle, for the degrees around the circle. We're going to change our measurements completely. We're not going to always refer to them in degrees. And anybody who's taking 4th course math, that would be trig or pre-calc, the sooner you get used to doing radians, the better, because it's all like radians. All radians. You do like this much degree and that much radians. So radians is the way to go. And it's going to be a little hard because you haven't done a lot with radians, so it's just a change. You're used to degrees. But we have to start getting used to radians. So what is a radian? You ready for this amazing video?
Sure. Let's go.
Oh, shoot.
What? It's not gonna work.
No, because I have some.
It's gonna work.
It will work.
It'll work.
Ooh. Oh, we have to skip the video
Suppose
first.
that you're ready.
I don't know what the sound sounds like for this video. Might have to mute it if it's annoying, but I don't know if there is sound. Okay. I did. Thank you. I'm gonna pause it real fast though, so I can explain.
It's not paused.
Trying to explain what's happening. So they're taking the radius, and they're taking the measurement of the radius, and then they're going to find how far around the circle one radius is.
What's this radius?
One radius. Radii is multiple. So they're taking the measurement, and what is it on our unit circle? Here it is. See, it's 1. So they're taking the measurement of 1 unit and finding where that is around the circle, right? Zone out and watch the circle. Good. So the arc length is 1 radius. Now they're going to take that, and they're sliding it. It's pretty good, huh? 2 radii. Now what they're doing is they're finding an angle that matches up where 2 radii are. That angle is 2 radians. A radian is the length of 1 radius. It's the angle that makes that length of 1 radius. So 3 radii, the angle is going to be called 3 radians. Watch, it's going to pop up real fast. 3 radians. Okay, I'm going to pause it for just a second. Now, 1, 2, 3 radians. How many radians is it to make a half of a circle? It's 3.14159 something or another. It's pi. How many radians will it be to make the full circle?
2 pi.
It will be 2 pi. Well, let's finish watching. You can watch it.
This is really cool.
It's not.
It's sort of confusing, but at the same time sort of not.
So 4 radii around the circle, the angle measurement is what? The theta will be 4 radians. Boom. There it is. You gonna keep watching it?
Wow.
No.
I know it is a little slow. Okay. Oh, you were saying yeah. So 5 radii around the circle.
This is video.
Like
17 minutes.
if I touch it, it'll pause. It'll take even longer. We don't have to finish it. I can do it.
Oh, please.
No, I want to see.
It's 3 minutes.
So here we are with 6 radii. See how it doesn't, 6 doesn't make the whole circle. It's actually 6.28-ish because it's exactly all the way around the circle, a length of 2 pi. So the radians around the circle, there you go, is 2 pi. So here we have some vocabulary. Bless you. Angles can be measured. I'm just missing a D. Angles can be measured using either degree or radians. There are how many degrees in a circle? 1 revolution is 360 degrees. 1 revolution. Because we could have 720 degrees in a circle if you go around twice. 1 revolution is 360 degrees. 1 revolution, how many radians are there? Oh, that's an approximate. How many exactly? 2 pi. It's approximately 6.28. We're really going to like to have exact answers, so where we can, we're going to use exactly 2 pi, where we're able to. Yes. I hope so. I think I am. Yeah. Let's do.
Thank you.
Okay, so 1 radian is the length of the radius, and 1 radian angle is approximately 57.258 degrees. So it's just under 60 degrees. That's why 3 of them fit in the top, and you still have a little bit left over. Because how many? Because 180 is the top, like 360s fit in. So these are each 57.2958. 1 revolution is 2 pi radians. A half of a revolution is even more important for us. Half of a revolution is pi radians, which is 180 degrees. We're going to use that more than the full thing. When we have triangles, what do all angles add up to? 180. So 180 is like used a lot more than a full 360. Okay, this page, we're going to go back to, when did you learn fractions? Kindergarten, first grade? We're going to go back and we're going to talk about pieces of a pie. We're going to talk about how you find the fraction for those. I unfortunately gave you the wrong one, the bottom corner. And so if you want to draw some lines in there and make it look like that one, and then the bottom middle, it should be like 6 pieces on the bottom corner, and then the middle bottom should be 12, so you can just divide the ones you have into halves. Sorry about that. I couldn't re-go print them after I did it. Just draw all the way through. We're going to talk about pieces of pizza. Read that. Well, some of you didn't learn it the first time, so we're going to talk about it. Huh? So the first circle is how much? 1 over 1. It's the whole thing, right? 1 whole. And what is the whole? 2 pi. This is all 2 pi. That's what I was thought. Because I wanted to write 1 whole, that's what I was thinking. So 1 whole is 2 pi. So then when we talk about dividing that up, half. Half is how much? It's half of 2 pi, right? If you take 2 pi and you divide it by 2, that's pi. Excellent. That was from chapter 7. Okay. Now, I have the rest of these, but I have them on separate pages so I can write bigger, so you can see it. They're all the same ones. They're just on different pages up here. Okay. So now what I'm going to think about is I'm going to think about only the top half, because that's going to be a lot easier to think about taking the top half and splitting it up. So when I talk about the top half and I split it up, how many pieces do I have in that top half? We have 2 pieces. Now the whole thing, the whole top half is pi. So then what is half of that? Or pi over 2. You can say half pi, but we always say pi over 2 for reasons. It means half pi. Okay? So when I'm thinking about adding pieces of my pizza together, and I'm thinking about this piece being pi over 2, and I'm supposed to be scribbling, nothing's happening. I'm thinking of that piece being pi over 2. When I add on a second piece, that's going to be 2 pi over 2. And then I add on a third piece, what's that one going to be? 3 pi over 2's. 3 pi over 2's. So I got 3 of these pi over 2 pieces. And when I add on the fourth piece, that one's going to be 4 pi over 2's. By the way, what does 4 pi over 2 reduce to? That's just 2 pi. I'm going to do it again. This one is actually the bottom right corner. It's underneath the one that I just did. So we're going to talk about just the top half to start, because the top half is how much? Pi. This might be one of the most important parts of the lesson. So if you have other things to do that are more important right now, you're going to struggle through this chapter, the entire chapter. This is probably one of the most important parts. One thing about radians, one reason why we use radians and not degrees is they are so much faster than degrees, and they are so much more accurate than degrees, because you know in the circle it has pi. Part of the area, part of the circumference is pi. It's not really degrees, it's pi. So understanding these pieces is so important. When I divide this into halves, the top half is how much? Pi. The top half is how much?
Pi.
The top half is how much?
Pi.
I don't see everybody answering, so I don't think everybody knows yet. The top half is how much?
Pi.
The top half is how much?
Pi.
Okay, it's very important that you know that. So if the top half is pi, and I'm dividing the top half into how many pieces?
4 slices of pie.
Mm-hmm. Oops. If only I could count.
1, 2, 4, 3.
I guess it didn't matter the order I put them in, right? So then the first piece, this piece right here, is 1 pi divided by 4. The first piece is that pi divided into 4. And then the second piece is 2 pi divided by 4. And then the third piece is 3 pi divided by 4. And the fourth piece is 4 pi divided by 4, which does reduce to pi. And then, seriously. And then what does this one reduce to? Pi over 2, which we know is pi over 2. It's over there. And if I keep going around, so that full thing is full pi, but there's more of a circle. So if I keep going around, I go past pi. What is my next one? 5 pi over 4. And then 6 pi over 4. And then 7 pi over 4. And then 8 pi over 4. And I could keep counting if I wanted to. And then some of these reduce, 6 pi over 4, same thing as 3 pi over 2. And 8 pi over 4 is the same thing as 2 pi. So if you have the pizza divided up the top half into 4s, you can label them all. The next one is this one. We're looking at the top half of the pizza. And it's divided into 1, 2, 3 places. So what is the first one going to be called? What, Nick? What? Yeah, but I'm not going to say the 1. But you're right. 1 pi over 3. And the second one is going to be called 2 pi over 3. And the third one is going to be called 3 pi over 3, which, yes, that is pi. But I'm saying the 3 just so we can know what the next one is going to be called. 4 pi over 3. And then 5 pi over 3. And then 6 pi over 3, which, yes, that is 2 pi. How many degrees is pi over 3?
60.
How'd you get that? Because the top half is 180 degrees, and we're taking a third of it. 60 degrees. Boom. You know what pi over 3 is equal to? What's 2 pi over 3 equal to? 120 degrees. It's 60 plus 60. All right, go to the next one. How many pieces of pie do we have in the top?
6.
And what is the radians for the top half? Top half, the top half, the entire half is pi. The entire half is pi. So one of those is pi over 6. Write it down. 2 pi over 6. 3 pi over 6. We're just counting. We're adding on more pieces of the pie. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And 12 pi over 6. Some of those do reduce. In fact, a lot of them reduce. Pi over 3. Pi over 2. 2 pi over 3. Pi. What is this one? 4 pi over 3. 3 pi over 2, pi over 3, and then 2 pi. So some of them did review. The angle for each one of those slices for pi over 6, the angle is how much? In degrees, I'm sorry, in degrees. 30. Or back up, go back to one previous one. This one here, what's the angle in degrees when we divide it by 4? 45 degrees. 45 degrees, 60 degrees, 30 degrees. Does that sound familiar at all?
Yes.
No.
Special triangles.
So this is going to come back to the special right triangles, not today, we won't do it today, but after break, all of this stuff is going to come together. Wait a second. Yeah, it's all coming back to SOHCAHTOA, it's all coming back to the special right triangles that you have to have memorized. What's the sine of 60? What? No,
45.
that's not 45.
Oh, wait, it's one out. Wait, which one did you say?
Radical 3 over 2. I said 60.
Oh.
See, we got to get these
You
things.
said
down.
sine of 60 or
I
cosine
said
of 60?
sine of 60.
Oh.
I was trying to get you to say the wrong one, and then it would be funny.
I don't know. For some reason I thought it was.
Sine of 30. Sine of 30
Is one
is
half.
a half. Sine of 60 is the other one, radical 3 over 2.
Two.
The sine of 45 is the one that's in the middle.
Radical 2 over 2.
It really can be done. It really can be memorized. Look.
I'm looking.
What's the sine of 30?
One half.
The sine of 60, you were telling me was square root of 3 over 2. The one in the middle,
Is radical 2 over 2.
so it's like, what is the radical of 1, by the way?
One.
So it's like radical 1 over 2, radical 2 over 2, radical 3 over 2.
1, 2, 3.
Uh-huh.
Yeah.
And it's in order, 30, 45, 60.
That's nice.
That's good.
What's the cosine of 45? I made a special
Radical 2 over
thing.
2. The same thing as cosine.
The cosine of 30.
1 half.
60, I mean. Is a half.
Yeah.
The cosine of 30. Radical 3 over 2. So once you have those, you know those. And then the tangent is still there. What's tangent? 45. Yeah. The tangent of 45 is when we do the two sides on top of each other. It's just 1.
Oh.
Because those are the same. And then the tangent of 30 is the one with all the 3's. So the cotangent, no.
Somebody thinks.
I know. Well, the cotangent, you can just flip the tangent. So if you know the tangent, you just flip it. But what's the tangent of 60? It's radical. Well, these are things you have to memorize. Spring break, just make yourself flashcards. Just do that every day. When you wake up in the morning, you're getting ready, let me just do my special right triangle.
Let's go.
Oh,
We got new one.
yeah. That's exactly.
Fair enough.
All right, last thing we're gonna do is if. Okay, so these that we just did, we just wrote radians for degrees. You just converted these radians into degrees. You just did that. You knew that if I take pi and I divide it by 3, I get pi over 3. If I take 180 and I divide it by 3, I get 60. You just converted between radians and degrees and radians. You just did it. Here's also a way to just start helping you remember. Pi over 3 is 60 degrees, and pi over 6 is 30 degrees. Pi over 3 is 60 degrees because it divides the top half into bigger hunks. And pi over 6 divides it into 6 hunks, so it's smaller chunks. Slice it. Two big hunks. You gotta know by now, I can't control everything that comes out of my mouth sometimes. Okay, pi over 4 was which one?
45, that's the one. 25.
So pi over 4 is 45. Pi over 4 is 45.
Whoa.
Pi over 3 is 60, and pi over 6 is 30. So you're converting these. You're converting these. If what is pi over 3 equal to?
60 degrees.
Then what's 2 pi over 3?
6 or 120.
Twice that. See? Right? Pi over 3 is 60, then 2 pi over 3s is 120. What is pi over 4? 45. So what's 3 pi over 4?
135. I did it on that. I did that in my head.
Good job. You see I'm converting these? You see I'm converting these? I'm using what we just did with pizza to convert them. Pi over 6. Pi over 6 is what? Oh, that's great. We'll let them. You missed all the fun. Yes, pi over 6 is 30. So then what is 5 pi over 6?
150.
Because it's going to be 5 times 30. What is 7 pi over 6? 730.
210.
And that, since the 7 pi over 6, 7 is bigger than 6, so I know it's greater than pi, which is greater than 180. Yeah. All right, so we're converting. Now, what happens when you have one that isn't special, where you just can't convert easily? There is a formula. And this formula I will not give you, but it is easy to do because it involves 180 and it involves pi. And we know that 180 is pi. We know 180 is pi because the top half is pi. That's 180 degrees. So it involves 180 and involves pi. So if you're given 120 degrees and you need to convert it, 120 isn't special, but that's okay. We'll still use it. If we need to convert it, what you have to think about with these formulas is you have to think about what you need to cancel out and change it into. So currently this is in what unit measure? Degrees. So I need to cancel out the degrees. That means when I multiply, I need to multiply by degrees on the bottom. So it will cancel the degrees on the top. So what is the degrees that I'm multiplying by? Yes, if you know it, you can just write it. But I'm going over how to do it if you don't know it, so we're using one. So your choices are pi or 180 degrees. What goes on the bottom? The 180, because we want the degrees on the bottom, so that means pi radians is on top. When we multiply fractions, we're going back to chapter 7, you multiply fractions straight across. And I'm showing all of my steps so that everybody understands what we're doing. I have 120 degrees pi radian over 180 degrees, and we start canceling things. So I can cancel out the degrees. You can cancel units, and if you've taken any higher level math or science classes, you probably have done unit conversions. And you will do it when you take physics. If you take physics, I know they like come to me and ask questions because they do a lot of this. So we can cancel out the degrees, and then we can also reduce the 120 and the 180 What can cancel out of 120 and 180? Right, 120 is 60 times 2. 180 is 60 times 3, so we can cancel out the 60s. What do we have left? 2 pi
Over
radians over 3. 2 pi over 3.
2 pi over 2 rad.
So do we have to?
It's just a unit, so I stuck it out.
Oh,
I mean, you can put it on top. Question.
we have to write radians?
You don't have to write the word radians if it's radians. If you don't write radians, I assume it's radians. If you don't write degrees, I assume it's radians. So you need the degree symbol. The radians is up to you if you want it. So you like, okay, I know this is radians. If you want to write radian, it's okay. Good question.
Pi cancel.
So I'm writing the radians just for notes. How about the other one? The other one is negative pi over 12. So let's look at this. What form is negative pi over 12 in? It's in radians because there isn't a degree symbol. So since it's in radians, I need to convert it to degrees. I'm going to be multiplying by something that divides the radians. So I can cancel out the radians. So if you need to write in the word radians here, it's okay too. Write that in. Radians. So what goes on top is degrees. We multiply straight across, and I get negative pi radian, 180 degrees, divided by 12 pi radian. And then we can cancel out on top and bottom things that are the same. Pi and pi, radian and radian. Does 180 factor to have a 12 in it by any chance?
Yes, 15.
It does. What is it?
15.
12 and 15. So I can cancel out the 12 and the 12. We write everything that's left over, a negative 15 and a degree symbol.
Could you not just divide the 180 by 12?
Yeah, that's what we're doing by canceling. That's what we're
Yeah,
doing.
but
Mhm. No, you can
we
totally
don't
do
have
that
to
way.
multiply it out.
No.
That-
But that's why it works. I'm just like pulling it back to what we learned. Yeah. All right, so before you start your assignment, you're going to complete a table and you're going to complete a chart. There are 2 missing values at the bottom of your table that I've added in. One of them is 1/6, one of them is 1/12. I'll start the table with you. I'll start the chart with you, and then you're going to fill in the rest. So this is talking about if I have a initial side and a terminal side, and it rotates 1 time around a circle. What's the degrees?
360.
What's the radians? All the way around. 2 pi. If it rotates around 180 degrees, what's the radian?
Pi.
Oh, radian.
Oh,
Radian.
pi.
And then what's the revolution? Okay, so you're going to find like the missing pieces. Pi over 2. So if we take the top half and we divide it into just 2 places, what degrees is that? You take the top half, which is pi, and we divide it into 2 places.
90.
That's 90 degrees. The top half divided into 2. How much revolution is that around the whole circle? 4. It's a half around the top, but it's 4 around the circle. Okay. And then on the other page, I'll just get you started on both and then you'll let you work. The other page, what we're doing are these are all the special ones. So you're going to attempt to write down their value in radians without the conversion, multiplication conversion thing. We already started it. Like 90 degrees is what? As radian. Right, we just said it, right? 90 degrees is pi over 2. 180 degrees is
Pi.
pi. 0 is 0, but at the same place, all the way around once is 2 pi. What is 270 degrees? So we've got pi over 2, 2 pi over 2, 3 pi over 2. So you can kind of use those pieces of pi that we could spend a bunch of time on to try to figure this out. All right, I'm gonna stop talking. You guys try these, ask questions before you get stuff. Yeah.
Does that mean like 1/3 is like the top or the bottom?
This 1/3 means of the entire
So it'd be
circle.
120.
So, okay, I will label, okay.
Let me get my answers. So we labeled 270 up there in purple. So 3 pi over 4, pi over 4 is 45. So 3 of those isn't even pi yet, yeah.
Yeah. Got it.
So it's gonna be 1/3 around the entire circle. So if the whole circle is that many degrees, what's 1/3 of that number? And then you can use this conversion, or you can start thinking about what 120 degrees is according to the pi that we did. But if you can't figure it out tonight, you can use the conversion and let you memorize it. Oh, yeah, that's what I'm saying. You're thinking of a sixth of pi, but we're talking about of the whole circle. This 1/6, that's of the entire circle, not of just the top half. So it's dividing the circle into 6 pieces. Do you know what I'm saying? I couldn't tell from your reaction. I think those are cool. So we're talking 1/3 around the entire circle.
It's only 23. Yeah. I did the, this is what I was late. Yeah.
You fill in the rest of those. Well, you can convert.
Oh, so should I go to this now and then use this one?
No, I want to get lunch done right now.
It's 90 plus 45. So it's 340.
So these are around here.
It's
Because we're talking about
345
1/6 of the entire circle, not just the top half. 1/6 of the top half is 1/3, but 1/6 of the whole circle.
Do all of the middle ones first, then just go straight answer.
Is what?
So like do all the 90s, do all the 45 degree equals. Then do all of the 30 degree because 30 and 60 are the same thing.
We're talking about when the circle is divided into 6. You gotta do this for all,
What do I need to do?
label every single angle in radians. So you get 4 of them, but there's like 12 more. So you gotta figure out what those are. because we're talking about 1/6, 1/6 of the whole circle. That we only have 3 to the top. Yeah. But then so you would be different. Those were right if it was the half the circle, they'd been right.
Yeah.
No. 60 goes in the top half. Pi over 3 is 60. How many times is 30? Oh, oh 120. So 120 is here. Right? And that's like what twice? We got some of them. Yeah, because 1/6 is like for the entire circle, not just the top. Entire circle. On this part? Okay, so 270. Where is 270? Can you drop into real quick? 270 is what percentage of a circle? How many fraction? Sorry. What percentage of the circle? So it's, yeah. And then 45 degrees, same thing. So then these are. That is. Okay, I'm going to talk about the chart. If you haven't finished it or if you got stuck, please check your answers because as I walked around, I saw a lot of the same thing wrong on every speaker, a lot of the same thing. So on the chart, I'm pretty sure I was recording this whole time too. On the chart, when we talk about like 1/3 revolution around the entire circle, that means the whole circle is divided into 3 pieces, the entire circle. So that's 360 divided by 3. That's 120 degrees. And then you can use your conversion that we just went over, or you could actually use the answer because we just went over it, 2 pi over 30. 270 around the circle, 270 is 3/4 of the way, so 3/4. And 270 as radian converts to 3 pi over 2. Pi over 4 is what degrees? Pi over 4 is 45. Pi over 4 is 45 degrees. So remember that. And then 45 degrees, if I think about a circle, 45 degrees is an 8. An 8. And the next one says 1/6. So I need a circle that is divided into 6. One of those is how far? 60 degrees. And then when we convert that to radians, 60 degrees is pi over 3. 1/12 of the way around would be like taking this one and dividing it up even more. We got 12 all the way around. That is 30 degrees. And 30 degrees is pi over 6. So over here I can start labeling some of them. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. And then we want to think about these numbers the rest of the way around. So 120 degrees, remember, is 2 60s. 120 is 2 60s, so it's 2 pi over 3. 135 is 3 pi over 4s. 150 is like 5 30s. So 5 pi over 6. 210, we did that one today too. That is how many 30s? 7 pi over 6s. 225 we haven't done today. 225, if you look carefully, it looks like it's exactly in between those. So it's a 45-degree multiple. How many 45 degrees fit into 225? 1, 2, 3, 4, 5 of them. 5 pi over 4. 240. What do I multiply together to get 240? 60. Huh? Oh, 60 and 4? Is that, I just couldn't hear. So 4 60s?
Yep.
So 4 pi over 3s? How do I make 300? 5 times 60 or 30 times 10? Either. So we'll do 5 times 60. 5, what's the 60? 5 pi over 3. 315 is right in the middle, so it's got to be a multiple of 45 degrees. And 45 degrees is pi over 4. How many pi over 4s is 315? 7 pi over 4. 330 is a multiple of 30. How many 30s? 11. So we do 11 pi over 6. Okay, this would be something else we are starting to memorize and figure out tricks to help us remember. You're going to use it over and over again. You have Big Ideas Online. You want to grab your computer, and we have a quiz. Go ahead, get up. Grab your computer. We have a quiz on Friday on 9-1 and 9-2. None of it is like you have to 100% have everything memorized yet. It's just you have to know how to use it.